But now also, since I have this diagram up here on the board, I want to just convey an idea that you, I think, are already familiar with, and that is this idea of shells. When you say a shell, you think of, well, the n equal 3 shell, the n equal 2 shell, the n equal 1 shell, right? But the word shell also connotes some spatial information, right? And you can see that spatial information here in this radial probability distribution function. What I want to point out is that the most probable value of R for the n equal 3 shell, well, those most probable values aren't identical for 3p and 3s, but they're very similar. They're similar compared to the most probable value for any electron in the n equal 2 shell. And those are similar than the most probable value for the electron in the 1s shell. So here you can see that spatial information. You can see that on the average, the n equal 3 shell is further out from the nucleus than the n equal 2 shell, than the n equal 1 shell. All right? So I just wanted to illustrate the concept of shells because we had that radial probability distribution function up here. And it shows you kind of nicely how those shells are indeed separated in space on the average.